The first thing that we talk about today is to find limit. The very basic is that one you can do direct substitution. So before we do that, let's look at some of the notation, and these are the property that you should remember. Okay, so let's B and C are real numbers. Okay, let me admit some of the student in. Do me a favor, if one of you can share the link again, so that way I don't have to do it. Okay, so let's say if B and C, so C, if you look at this, what I mean by C. Okay, C is this values right here. Remember, that's the X values that you look at. When X is 3, approaching 3, X approaching 1, think about the bell ringer, the X values that we looked at. And then we have the B is the limit that we look at, okay? So it's a limit, this one is mean the limit of a constant. If you look at this one, so think about the graph earlier. If we think about the graph that we had earlier was, let me share with this one. This is the graph. Think about this. If this is a graph, okay, and we find the limit when X is 3, and I noticed some of you kind of draw that line, which is good, and then we know the Y values is approaching, right? So that's at 3, which is 2. That's the limit. So right now we're going to look at this graph. Think about this one. If you can think limit of 5, the limit of a constant, this is 5, is the same as Y, too big. This is the same as the function Y equal 5. That is the function that's given to you if it's the constant. So anyone remember, if we're going to sketch a graph of Y equal 5, what is the graph going to look like? This is your Algebra 2 skill or pre-cal skill, if anyone remember. What kind of graph is this? It's a horizontal line, right? Yes, it is a horizontal line. So if I'm going to sketch the graph, look like this. This is the x-axis, this is the y-axis, right? So let's look at the line. It's going to be like this. This is y equal 5. Okay, this is a graph. Now, if I want to know what happened at 2, so 1, 2. So what is the limit when x is 2? Is that when it's x approaching 2? What is the values that we may see? Is 5. Good. What about instead of 2, if I change this to the limit when x approaching -1? What is the limit of -1 then? Still 5. What if I change the limit at 0? What is the limit going to be? Still 5, right? So this is a horizontal line, so it doesn't matter what x values would be, the limit is always that values. So if you look over here, limit of 5, the limit is going to be 5. Okay? It's always, because this is a straight line, doesn't matter where I'm looking at the graph, that y values never change. So that is the first property, something that you should have it memorized. So it's make it easy for you. You don't have to look at graph. Like, okay, the limit of that constant is that constant. Okay. All right. Question for me on the first property. We have 2 more people who just joined. One of you share the link again for me. Thank you. Thank you, Justin. Okay, so now the next one is a straight line, a linear function. This one I call the linear function or straight line. Okay, if we have a function, think about this graph. Y, if this is a graph, it's the x. So this is the sketch of the graph that I have. Okay, this is a straight line, so we know this is the graph. That is a graph. Okay. So this tells you if we have a straight line, so this is 1, 2. So think about this. That is fine. If you got kicked out, just come back in. Make sure that if the link is not working for you, check again, okay? So if you look at the limit of this function, let's say if I want to find the limit at 2, this is the example I'm using. What is the limit at 2? What is the values? It would be 2. What about at 1? It's 1. What about at 0? It's 0, right? So basically what this tells you that if you have a straight line, y equal x, which is the limit of just x values, the limit at that point is that the x values that's given to you is 2, okay? So that's the difference between example 1 and example 2. Example 1 is the y value, is the limit, because that's the horizontal line. The example 2 is the linear function. We look at the x and that give you. If you're not sure, we can always test by using the table. We can test using the graph. We can look at the graph. But that is the example that I have for the first two. So that's the difference between the two, okay? Question for me? Is okay? All right. So let's look at the next example, which is x to the third power. We're going to sketch this graph. So this is when, if you look at this function, is x to sum of the number. The property would be the c, which is the x value, will raise to that power, whatever the power that is. So what tells you is that this value is c, the c is 2, whoops, the c value is 2, and the power that we have is 3. So that's mean to find the limit, I'm going to use a property given to me, which is the c is 2, the power is 3, the limit is going to be 8. Okay? We can prove this. That will be the one that we're going to use. But we want to prove this by looking at the graph when x to the third power. If you're going to sketch a graph to the third power, I'm going to do my best to sketch it here. Let's look like this. Let's look like this. Okay. If you have a graphing calculator, you can grab it in and you can look when x is 2, the y value is actually 8. If we look at the graph. So it's harder for me to draw in here, but that's what it looks like, okay? So this is what these are the 3 properties that I want you to have it memorized so you remember. If we have a constant, that is the limit. If we have a straight line, just the linear function, just the x, then we just replace with the x with the whatever the x values that we want. We get the limit. It's the same thing if s to any power, we take the 2, replace for the x, and raise that to whatever the power that's given to you. And that's how we find the limit. So we can use algebra to find limit. Okay, questions for me on this? All right, so let's look at the example that we're going to have. Because we know if the function, we're going to use direct substitution. Based on the third example, we know that by look at the x and we want to know what happened at y, we're going to do direct substitution. So the first way to find the method is pretty straightforward, and I think we're going to feel comfortable. For this time, we're going to learn how to write the limit. We're going to write the step. We're going to write proper notation. So if you have paper, I'm going to ask you to write on a piece of paper or a notebook, whatever works for you. Okay, we can use direct substitution. What that means is that I'm going to look at the c value, which is the x. And that is the values that I'm going to replace it in. So to find the limit, this direct substitution method is what we do. Instead of x values, I will replace the x values with 1. How do you know 1? Because it's tell you right here x approaching 1. So I want to know what happened at 1. I'm going to write a little bit big, so I'm going to write it down here. So 1 square plus 1 plus 4, 1 plus 1, that would give you 6 over 2. If I simplify, is 3. So that's the limit of this function. So this is called direct substitution. What I do, I'm taking the x values, plug into the equation, and that will give me the limit. Easy enough? The only problem is that when you run in, if you're going to use a calculator, if you don't do it right, you may get a wrong number, okay? All right, so I'm going to ask you, okay, in product, I'm going to ask you to do these two for me. Go ahead and start. Okay, so the second one is 1. So how is 19? We plug it in. This is called direct substitution. So I replace the x with 2 plus 3. So I know it's 2 is right here. Tell you to replace the x value with 2. 4 times 4 plus 3. This is 16 plus 3, which gives you 19. Okay. So if you're not sure what to do, I'm showing you how to do it. And if you go back to Zoom, then that will show you. Okay. Then for number 2, sine of pi over 2, which is 1. If you use a calculator, plug it in, that will give you 1. All right. So that's good. We got it. It's direct substitution. Not much we need to do. Let's move on to, so we have a few more examples for you to do, but I think it should be okay. The one thing that I'm not going to ask you to do all of them, but I want you to practice how to, if you have the time and you want to practice how to use your calculator, is pretty much plug it in. So instead of do all of this, I just want to see how you do, let's do number 32. Let's do 32, okay? The reason I want to do 32 is that it's not difficult. You plug it in. But I want to know if you can use your calculator properly. Because if you don't, you may not get the correct answer. Okay, so we all know that we're going to plug it in. 1 square plus 5 over square root of 3 times 1. Go ahead and put that in your calculator. I'm sorry, times 3. I plug it in wrong. I'm so sorry. Okay, x is 3. So go ahead and plug that into your calculator and see what is the answer. Okay, so right, for this one, I'm just kind of check in. So see how well you use your calculator. We know we just plug it in. It's gonna get harder, okay? What happened when you cannot do direct substitution? For example, we're gonna run into a problem that if you plug it in, it's not gonna give you the number that you want. There's a problem because there's a hole at that point. You plug it in, it's not going to work. How do you know without look at the graph, right? Remember when you have this graph, we want to know what happened at 1, we kind of look at the y values. We look at the graph and we say, okay, at this point it's got closer and closer to 1. That's how you know. But without the graph, what can you do, right? Because over here, we can test it out. So step number 1, this is what you always want to do. When you run into the problem asking to find the limit, plug it in the number and see what happens, okay? So that's going to be -3 squared plus, if you can go back to the screen, I'm going to go over the new note, -3 plus 3. Okay, so if I'm going to do this one, it's going to be, don't copy this, you can copy this down on a piece of paper if that helps you, okay? This would be 9 minus 3 minus 6 over -3 plus 3, that will give you 0. Okay, up here, 9 minus 3. 9 minus 3 is going to give you 6 minus 6. So here's the problem. When you do direct substitution, if you run into the problem that's 0 divided by 0, this one is, you don't know what happened here. It's not undefined. It's not, this doesn't mean does not exist, right? So for this one, when you have this case, direct substitution is not going to help you because I don't know what is the limit. 0 divided 0, I don't know what that is. We cannot divide by 0 anyway. So here's the problem, right? If you run into like, okay, my denominator is 0, I cannot divide by 0, I don't know what my answer is, my calculator won't tell me, right? If you put in your calculator 0 divided by 0, there was like error, I don't know. So this is your Algebra 2 skill or pre-cal skill needed. I'm going to clear this. This is a method that we want to review. So here's the thing we're going to call is factoring method. This is quadratic function. Factoring method. So this is the method we're going to do. So what I would do is that I'm going to factor out the numerator. So here is the way that I'm going to write my function. Notice this is going to be the proper way of writing limit notations. I'm going to ask you to have this down. For the next summative, I will for sure pay attention to the limit notations. If you make a mistake with limit notations, I will take up points. The last time I was like, I'm just ignored. I just want you to like understand limits and what that means. All right. Let me check to see if anyone have any question for me. Nope. Okay. So what I would do is called factoring method. Remember the factoring method. If you factor it out, this will be this 2 factor. It's going to be x plus 3 and x minus 2. At this point, I'm going to ask you to be honest with me in the chat. If you was like, I remember, I don't need to review. We're going to move on. If you was like, this is something that's missed when I don't remember how to factor, please pause and review how to factor before we finish up with this one. Okay. So some remember, some need to review. Okay. All right. So what I would do, I'm going to do a quick review for the one was like, I don't remember. And the one remember, just bear with me. Okay. Give me like a minute or two so that I can kind of remind people what to do. And then we'll finish up with this problem. Okay. So we're going to finish up with this problem. Then I'm going to review how to factor it out. Okay. So you look at this one. Once I factor this out, if you look at my terms, look at this one and this one. Match. What that means, I can cancel this one out. So once I factor it out, the reason I factor it out so that I can cancel out one of the term in the denominator, because the denominator is a problem. When I plug the -3 in, it will give me 0, and I don't like divide by 0 because I don't know what happened. So this will cancel out. It's going to be limit x approaching -3, x minus 2. Now, nothing wrong with this function anymore, which I can plug it in the -3 minus 2 give me -5. And this is the limit. So step number 1 for this one is that I'm going to factor out the quadratic function that's given to me. This is step number 1. Use different color. Step number 1, I will factor it out. Step number 2 is that I'm going to cancel out the common term, the common factor. Step number 3, once I cancel this out, I'm just going to write out whatever I have left. I simplifies it. This is what I have. And then the last step would be I plug it in. Notice when I plug it in, I don't write the limit notation anymore. Okay? You have to write the limit notation. This one, you keep writing it. You only stop writing it when you do substitution. Once you plug it in, then you can stop writing limits. Okay, so this is new, and I'm like, some of you are like, what is going on? It's fine. It's okay. We'll do more example with this, so that's okay. So for now, I want you to understand the process first, and then I will spend the time to review how to factor it out. Is that okay? So for now, I will factor that one out for you, and I'm going to ask you what to do next. And in about the last 10 minutes, I'll review how to factor it out, okay? Does that work? Okay, so we have half and half. Say yes, I remember. So I'm like, nope. So we'll spend the last 10 minutes to do it. Okay, let's look at another one. Okay, I know for those like I don't remember how to factor, just bear with me. I'll factor this one out for you. Then we're going to review how to factor, okay? So step number 1. I'm going to ask you to put in the chat. Which one, how do I know if I factor it out? Because think about this. I put the 1 in here. 1 minus 1 is going to be 0. If I plug the 1 on the top, 1 minus 1 is going to be 0 over 0. So if I test it out, 0 over 0. That's not an indeterminate, which means I don't know what happened. So I have to factor it out. So limit when x approaching 1. The bottom, the denominator, there's only one factor, so I'm not going to do anything. But I know I'm going to have 2 factor in the top. For the one who remember, what are the 2 terms that I should put on the top? If you said you remember. If you don't, that's okay. We'll do this together. So you just have to jot it down and understand the process first. Okay, so I have x minus 1 and x plus 1. Okay. That is correct. X plus 1, x minus 1. So that's step number 1. I will factor it out. So step number 1, factor it out. What is step 2? What is the reason for me to factor it out? What is the goal? Why do I spend the extra time to do this? For what? To simplify, to cancel out the denominator or cancel out one of the term, right? Like you don't want to do extra thing. Like you don't want to do something like then what, right? So I factor it out. Now I notice x minus 1 and x minus 1 is the same. So I go ahead and cancel those out. It's multiplication, so I can cancel that one out, okay? So when I do this, I'm just going to write what I have left, which is x plus 1. Now, my denominator, the one that gave me the problem, which is, remember the problem they gave me? Divide by 0. I have that problem. So when I have this, x plus 1, now what should I do next? Now I have the limit x approaching 1, x plus 1. What do I next? What is my next steps? What should I do? Plug 1 in for the x. Yes, so this 1 will be in here. So 1 plus 1 give me 2. This is my limit. So like I said, the calculus steps is really the plug it in direct substitution. I plug it in. The algebra 2 or the pre-calc skill, that's the one that some of you want to remember, is to factor it out. So like I said, calculus concept is not that difficult. I think it's fine. The problem that most of the student are the pre-calc and algebra 2 skill that we needed. So the limit for this problem is 2. Again, notice I have to write the limit notation all the way until I do direct substitution. Then I can stop writing the limit notation. So this is the proper. So I keep writing limit x approaching 1, limit x approaching 1 until this one. So question for me on the steps. Step 1, step 2 that I cancel out. I rewrite the function. Step 4, direct substitution. Step 1, 2, 3, 4. Any question for me in those steps? Okay. All right. Let's do another one. Okay. I want to use this one because it's not every time that we will have to factor out the numerator. Sometimes we have to factor out the denominator as well. So we factor the one with the power. That's the one we need to do. Because y, if I plug it in, negative 2 plus 2 over negative 2 squared minus 4 is going to be 0 over 0. That's giving me a problem. It's indeterminate. Okay, so I'm going to write this one out. Okay. Limit x approaching negative 2. The top is the one that I will keep. The bottom, let's see. Okay, thank you, Jessica. It's going to be x plus 2 over x minus 2. Okay, so that's step number 1. I will factor it out. Step number 1. Once I factor it out, I have to simplify this one. I'm going to cancel out. What term or what factor can I cancel it out? The x minus 2 or x plus 1? Anyone else besides Jessica? X plus 2, right? Because that's the one is the same. So I'm canceling out the one that match. Thank you. So limit, again, I have not do direct substitution yet. So I'm not going to, I have to write out the limit notation, okay? So when you cancel this one out, it doesn't mean that mean you still have something. This is a fraction. So when you cancel it out, it's like 1. Be very careful with this one, right? Because a lot of you was like, oh, I will end it up with x minus 2. No, it's 1 over x minus 2. Okay, be careful, all right? Because when you cancel this out, it's like you have a 1 up here. Okay, now I can do direct substitution, which is 1 over negative 2 minus 2, give me negative 1 over 4. So this is my answer. Okay. All right, I think that should be enough for you guys to start to do practice on the next couple slides. For the one where I missed one, I need to review how to factor it out. I will do that with you now. And the one, I'm going to turn this into student pace. So that way you can do the next couple of slides. For those like, I know what to do, go ahead and do that on your own as practice. And for the one like, I don't know, I need to review how to factor it out, then you can follow with me on how to do this, okay? So let's see, I'm going to turn this into student pace. All right. So right now, you guys should be able to do this on your own. So I'm going to ask you to do the next. We have about 5 minutes. So I'm going to ask you to do the next two slide. Two slide. Okay. I will check in with you. I will check in the work at the end of the day today. So do the next two slide, and the one who need me to review, or you don't know what to do, you can just stay and follow with me on these, and that would be okay too. So let's do the next two slides by yourself, or stay with me, and we're gonna review this. Okay, so we're gonna review how to factor it out. So I know the one that I will factor out is x squared minus 4. This is a special case. Some of you already know it right away, which is x minus 2 and x plus 2. But if you don't, this is a method. We're gonna identify a, b, and c values. So remember, I have a x squared plus bx plus c. So a is a coefficient in front of the x squared. So in this one, a is 1. B is the one in front of the x. In this one, I don't have b, which is 0. C is a constant, so that is 4. Okay, so to factor this one out, I'm going to show you what we do. So remember, this is called the diamond method, or the X method, whatever. I think Miss Conan called. We use a punished way and all of that. In this case, because A is 1, I don't have to use a punished where. So the top is A times C. This one is B. Okay. So A times C, which is 4. The B value is 0. So what you need to do is look for two numbers. If you multiply, so I'm going to write this up here. If you multiply, it will give you this values. But if you add, give you this values right here. So what are the two numbers? If I multiply, would give me 4, but I add would give me 0. So I can list those out. These are my options. 4 times 1. Okay. Well, if I add them, it's not going to get 1 times 4, not going to work. 2 times 2. I'm sorry, the C is negative 4. Okay, so I can have negative 4, negative 1, but if I add them, it's not going to use, yes, use of is negative 4. And then I can do 2 and negative 2. So which pair? I know this one, if I add them up, it's not going to get me, so this cross out, so I end up with 2 and negative 2. So if I factor this one out, it's going to be x plus 2 because this one is positive, and then x minus 2 because that's negative. So that's my factor. Okay, so that's how I factor for this one. This is a special case, so you can see that. Let's do another one with factoring out. I'm not going to do limit for this one because I'm going to ask you to try that on your own. But if I look over here, I could do another. This is the 1, right? So A is 1, B is negative 2, and C is negative 3. Okay, so to factor it out, A times C, and this one is B. So A times C is 1 times negative 3. B is negative 2. All right, so let's look for the pair. It's negative 3 times 1, 3 times negative 1, and I think that's all the option that I have. But which pair should I use? Because if I add them, it should give me negative 2. So this would be the pair because negative 3 plus 1 give me negative 2. So negative 3, 1. That's how I factor it out. Right, for the one was like, I need to review. You want to do another one, and you think this is okay, or you can do more practice later. Let me know. Is another? Should I do another one? Or you like, I think I remember now. I'm like, nope, still not remember. Can you do another one? Okay, a little bit better. Okay. Next time when I see you, it should be on Monday. We go over when A is no longer 1, when A is like 3, 2, and then we'll do the Punnett where. So that will be a little bit later. Okay, cool. All right, so I'm gonna ask you, this is your practice, is that you're gonna do the next, these are the 2 slides that I want you to, once we already factor it out, right? This one and this one. I'm gonna ask you to take the time today to practice on these 2 slides and find the limit for me, okay? This one and this one. If you don't do this on paired act, you don't do in this slide, I'm going to ask you to take a picture, do it on a piece of paper, then can you email that to me? I just want to see where you are and how much should I review and do, what kind of example should I do with you the next times, okay? So do this one, this example, and then this one, which I already factored it out for some of you who needed the help. Okay, find the limit for those 2. Email me the work, or if you do it in paired act, then that's fine. I should see it. It's not due today. I'll give you more time to work on it. So if you can have it by tomorrow, that would be nice. That would be great, because by tomorrow, I can plan for what to do on Monday. So that would help me. If I don't see the work, I assume we're okay. I'll move a little bit faster. Does that make sense? Like, it's really helping me to prepare for the next lesson. Okay. All right, it's 8:50. Thank you. Make sure that if you want to take that test today, is at use Flip Remote link at 12:45. I will be there, and then you can take the test. If you want to do retake, again, come to see me today at 12:45. I'm going to review with you, and then you can do retake, right? Bye, everyone.